So our next step here is to talk about the three remaining trig functions. There are six total. We already know about sine, cosine, tangent. The three additional trig functions are called secant, cosecant, and cotangent, and that will be it. I mean, I already be wondering, like, where the heck is this going? Why do they need six? We can talk about that as we go along, but the fact of the matter is there are six. And so let's go ahead and define secant, cosecant, and cotangent. I'm going to draw a right triangle. And follow our usual convention of labeling angle C as the right angle. A and B are the two acute angles of the right triangle. And then across from C is little c, the hypotenuse. Across from A is little a leg. Across from B is little b, the other leg. So first, the secant. So we'll just talk about the secant of angle A, and that's abbreviated SECA. So secant is a ratio you get by taking the hypotenuse divided by the adjacent side to A, which in my picture is actually C over B. Now, I don't memorize this, I never have. What I observe is that this C over B is just the reciprocal of cosine. We've just flipped the cosine fraction. And so another way to write this idea that this fraction is the reciprocal of the cosine fraction is to just say this fraction is equal to 1 over cosine of A. And that's what I remember. I remember that secant is 1 over the cosine. Cosecant. Cosecant is CSCA is the abbreviation. That's defined by the ratio hypotenuse over the opposite side. So that's going to be C over little a in my picture. And notice that that's just the reciprocal of sine. So we can always say that cosecant A is 1 over the sine of A. And cotangent, which is abbreviated COTA, is going to be equal to the adjacent side over the opposite side. So for angle A, the adjacent side, that's B over adjacent side is, opposite side is A. And notice that that's just the reciprocal of the tangent of A, so we can say this is 1 over tan A. So what you want to remember isn't so much all these different ratios, but I just memorized that secant A is 1 over cosine A. Cosecant A is 1 over sine A, and cotangent A is 1 over tangent A. And let's maybe put this in a box. I would just focus on this. So secant, cosecant, and cotangent can be defined from cosine, sine, and tangent. These are called the reciprocal relationships. And I want to show you an easy mistake to make, and this is the mistake. I hate to mention a mistake, but it's one I used to always have trouble with. I used to get mixed up with secant going with cosine, cosecant with sine, I would sometimes accidentally think that secant was 1 over sine. Somehow that seemed to make sense in some twisted way to me, and that's wrong. Secant is not 1 over sine. You have to be able to keep secant associated with cosine, cosecant with sine. Cotangent with tangent usually isn't a problem for people. So what you might notice is that each one of these three equations, so there's this one, and this one, each equation, each reciprocal relationship equation has only one cofunction. The cofunctions are cosine, cosecant, cotangent. So secant's not a cofunction, but cosine is. So secant and cosine, that equation has one cofunction. Cosecant's a cofunction, sine is not. This equation has one cofunction. Cotangent's a cofunction, tangent is not. This equation has one cofunction. And that's always helped me remember that to get these three equations correct, that the reciprocal relationships involve only one cofunction. So secant not co goes with cosine is a cofunction. Cosecant's a co goes with sine not, and so on and so forth. Okay, there's another observation that we want to make at this point, and it involves looking at sine of an angle divided by cosine of an angle. Now, sine of A would be opposite over hypotenuse. This is just good old SOHCAHTOA. Cosine is adjacent over hypotenuse. So this fraction of fractions I can think of as a division problem, opposite over hypotenuse divided by adjacent over hypotenuse, right? And so when I invert and multiply here, so leave the first alone, take the reciprocal of the second, I get opposite over hypotenuse times hypotenuse over adjacent. The hypotenuse cancels, and I end up with just opposite over adjacent. That's tangent, right? So tangent A is equal to sine A over cosine A. That's a useful relationship to know. Tangent can actually be expressed using sine and cosine. We have two different ways of thinking of tangent. And we can connect that to cotangent, which we know is, we just said, is 1 over tangent, but then the reciprocal of tangent would be cosine A over sine A. Flip that fraction around. And I'd say the moral of all this is that all 6 of these trig functions can be expressed using just sine and cosine. And you want to know that. You want to learn that. So I have another yellow card here with really important information. That this is our third yellow card number 3, where you definitely want to have memorized that secant is 1 over cosine, cosecant is 1 over sine. Tangent can always be thought of as sine over cosine. Now we still have SOHCAHTOA, we're not throwing that away, but sometimes it's useful to think of tangent as sine over cosine. And for that matter, cotangent, which is the reciprocal of tangent, is cosine over sine. So for any angle theta, we can obtain secant, cosecant, tangent, cotangent from sine theta and cosine theta. Often in problems, we'll just figure out what the sine of theta and cosine theta are first, and then we just write down what all the other functions are just from sine and cosine. So we'll do an exercise with this in the next video.